Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Evaluating Model Performance. Evaluating model performance is a critical aspect of machine learning and is essential for ensuring the effectiveness and reliability of generative AI systems. As leaders in the field, it's vital to understand how to assess model performance to make informed decisions and optimize the deployment of AI solutions. This lesson delves into the methods and metrics used to evaluate the performance of machine learning models, emphasizing their application in generative AI. The evaluation of model performance begins with understanding the objective of the model. In generative AI, this often involves generating data that resembles a given distribution. Whether the goal is to produce realistic images, coherent text, or predictive outcomes, the evaluation metrics must align with the specific objectives of the model. One common approach to evaluating generative models is through quantitative metrics, such as accuracy, precision, recall, and F1 score, particularly in classification tasks. These metrics provide a numerical representation of the model's ability to correctly predict or generate outputs. Accuracy is the simplest performance metric, representing the ratio of correctly predicted instances to the total instances. However, accuracy alone can be misleading, especially in imbalanced datasets where one class dominates. Precision and recall offer a more nuanced view. Precision measures the proportion of true positive predictions among all positive predictions, indicating the model's ability to avoid false positives. Recall, on the other hand, measures the proportion of true positive predictions among all actual positives, reflecting the model's ability to detect all relevant instances. The F1 score, the harmonic mean of precision and recall, balances these two metrics to provide a single performance measure that considers both false positives and false negatives. In the context of generative AI, specific metrics such as the inception score and Fréchet inception distance are often used to evaluate the quality of generated images. The inception score, proposed by Salamans et al., relies on a pre-trained neural network to assess the diversity and quality of generated images. It calculates the KL divergence between the conditional label distribution and the marginal label distribution, with higher scores indicating more realistic and diverse images. The Fréchet inception distance, introduced by Heusel et al., measures the similarity between the distributions of real and generated images in the feature space of a pre-trained inception network. Lower Phi-D scores indicate closer resemblance between the two distributions, thus better generative performance. Another essential aspect of model evaluation is the use of cross-validation techniques. Cross-validation involves partitioning the dataset into multiple subsets, training the model on some subsets, and validating it on the remaining ones. This process is repeated several times to ensure that the model's performance is consistent across different data splits. K-fold cross-validation, where the data is divided into K subsets and the model is trained and validated K times, is a widely used method that provides a robust estimate of model performance. Beyond quantitative metrics, qualitative evaluation plays a crucial role in assessing generative models. For example, in text generation tasks, human evaluation is often necessary to judge the coherence, fluency, and relevance of the generated text. This involves subjective assessment by human reviewers who rate the outputs based on predefined criteria. Human evaluation is particularly important in applications where the subtleties of language, context, and creativity are challenging to capture through automated metrics alone. The evaluation of model performance also involves understanding and mitigating overfitting and underfitting. Overfitting occurs when a model learns the training data too well, capturing noise and specific patterns that do not generalize to unseen data. This results in high accuracy on training data, but poor performance on validation or test data. Underfitting, conversely, happens when a model is too simple to capture the underlying patterns in the data. leading to poor performance on both training and test data. Regularization techniques, such as L1 and L2 regularization, dropout, and early stopping, are commonly used to prevent overfitting and enhance generalization. Furthermore, the evaluation process must consider the interpretability and explainability of the model. In many applications, especially those involving high-stakes decisions, such as healthcare, finance, and legal systems, it is crucial to understand why a model makes certain predictions. Techniques like SHAP and LIME provide insights into the contribution of individual features to the model's predictions, enhancing transparency and trust in the AI system. Lastly, the deployment of generative AI models necessitates continuous monitoring and evaluation. Model performance can degrade over time due to changes in the underlying data distribution, known as concept drift. Continuous monitoring involves tracking key performance metrics and retraining the model as needed to maintain optimal performance. Automated monitoring systems and alert mechanisms can help detect performance degradation early and trigger necessary interventions. In conclusion, evaluating model performance is a multifaceted process that requires a combination of quantitative metrics, qualitative assessment, cross-validation techniques, and continuous monitoring. Understanding these evaluation methods is crucial for modern leaders to ensure the reliability, effectiveness, and trustworthiness of generative AI systems. By leveraging these evaluation strategies, leaders can make informed decisions, optimize model performance, and drive the successful deployment of AI solutions. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.